Don't talk. Take it. So let's continue with this sheet. We will still leave the 8, 9, 10th question where I will try to discuss it in the study hour, okay? I want to start with a new chapter now as soon as we can. And question number 11 I told you to do yesterday, na? What was the graph that you were getting? The question was something like you have a source which is moving from Vs in a line joining the SNO, and now you have to plot the frequency heard by the observer versus time graph. So how will the plot look like? It's very simple, that as the source is going towards the observer, then what is the frequency heard? In this case, that will be V by V minus Vs into F, no? Yes or no? And at the instant when the source is just at the point of observer or maybe near to it, at that instant what is the frequency heard? That's F. At that instant it will be F. And when it goes away from the observer, then what will be the frequency?
Minus Vs into F.
No, V by V plus Vs into F, na? As it goes away. Yes. And as you can see, all these frequencies that we find, they are not functions of distance or anything. They are purely dependent on speeds. And for a constant speed, this becomes a constant. Yes or no? So let's say the time taken to go from here to here is T naught. Then what is T naught? Let's say the distance covered is D naught. Then speed equal to distance over time and time equal to distance over speed. D naught by Vs, na? This is the time taken to cover that thing. So if I want to plot it, so ye D naught by Vs, when your time starts from 0 to this thing T naught, then what is your frequency? It's a little higher, no? What is that frequency equal to? Bata? V over V minus Vs into F. That is that frequency. As soon as you hit this time, then what does your frequency drop to? It drops to F. Yes or no? This is the point. And as soon as you go away from it, then your frequency drops to here. Some other value, some other constant. Yes or no? So it's a discontinuous graph. What is this frequency? This is F. What is this frequency? That's V over V plus Vs into F. So the frequency is a constant. From some time to some time, it's a constant, drops to some value, then drops again as you go away. Does it make sense? Yes, Swanan, understood? If there is anybody who did not understand, then please ask. This is the frequency versus time graph as a source is moving towards an observer. Okay. Now there is a question number 12, and if you read it, it's exactly like the same one question that we have already done. A source which is moving in a circular path and an observer which is a little far away, and you have to find the max and min frequencies and where should you hope to find it. ये सब है ना, तो I think we have done this question already. So I'm leaving it to you, and I'm starting with a new chapter today. So, which question?
The orthodox method we get the wrong answer.
I know.
Why are we getting that?
I did not check it later. देखता हूँ, बाद में देख के बताता हूँ. You remind me again in the study hour, and we'll see. So let's take it to be the homework. Question number 12. It's very simple, and I'm starting with a new chapter. Is it done by everyone? So let's start with our discussion on wave optics. Lecture 1. Okay. If you remember that we started out the whole year's discussion, we started with ray optics. And do you remember what was optics? The study of light. Yes, and we try to understand light or its behavior by assuming that light behaves like a ray. है ना? We took this description and then we tried to prove some laws and try to understand the light behavior, and we actually were successful when we were studying reflection and refraction and dispersion. These three things we can understand by rays. But there are some more phenomena that light shows which you can't explain by just ray ka description. And if you remember, the first line that I ever wrote for ray optics was, rays are just our imagination, rays do not exist. The general thing is waves, and rays are just an approximation. If you remember, that was my first line of the chapter. So let's come back to the general description and let's try to do everything based on this, and let's try to actually understand some phenomena that ray optics can't explain, and we have to use this wave optics. And the phenomena, I'm listing out some of them, we will try to understand as we go along. The first is interference in light. Interference. Then there's something called as Young's double slit experiment. I will call it YDSE. Then there's something called as diffraction. These are all the contents of this chapter. And then something called as polarization. These are all phenomena, at least these three, interference, diffraction and polarization, which light shows, and you can't actually understand these phenomena by ray optics. That's why we go to the general setup, wave optics. And why did I go from ray optics not to wave optics directly? Because you did not have a picture in your mind of what is a wave, and then we took this turn around and we discussed about waves, the whole thing, you know, just to get an understanding of what is wave. And now we are equipped with that. Let's do it, wave optics. If you go in a linear fashion, then actually before this chapter there is another chapter which is called electromagnetic waves, and there you understand that light is an electromagnetic wave. We have not studied that, so I am just writing that statement here. When you go to that chapter, you will understand. Okay? So light, so hopefully you are writing with me, is an electromagnetic wave, and all electromagnetic waves are independent of the medium. Now they don't need medium in general for propagation, so do not need medium for its propagation. Yes, it's a transverse wave. You will understand how when you study electromagnetic waves, but I'm just writing it. A transverse wave. And then there's something called a speed of light. Do you know that? That's c, 3 into 10 power 8 meter per second. Or more precisely 299792458 meter per second. Anyways, you remember that value. That's approximately the same thing. ठीक है. So this is wave optics, and we'll try to study this. And the thing is ki the first discussion of interference we have done already. When we were talking about this superposition of waves, then I did a huge discussion on interference. In general, that was a discussion that you can apply for any wave. Okay. So you remember the condition of getting maxima and minima, the path difference, phase difference conditions that I found out. We found those things, so I am not re-deriving all of it again. It will just be a repeat. So I am skipping that, and I am going to this topic of Young's double slit experiment. So let's start with it. Experiment. One of the most important and historically renowned experiments in physics. You will understand its significance when we talk about modern physics. Okay? It's a very, whatever we will discuss here, you will not be able to relate it, but when we will talk about modern physics, it will all be clear. For now, I am just talking about what is the experiment. Young's was a guy, okay, his name, and this double slit experiment is basically you have two slits. Do you know the meaning of slits? You can open and close them. So you have two slits here, and let's say in behind them there are two sources, S1 and S2. Okay, from these two slits light will come out. Please remember that our discussions up until now were mostly of mechanical waves, but now I will talk about light again. So don't have a description कि particle will oscillate in mean position, वो सब नहीं याद रखना है. Light का motion imagine करना है. These two waves are, इधर से waves आ रही है, and let's say there's a screen here. This is my 2D screen which is coming out like this. ऐसा कोई screen है. Screen, and on this screen we will find a pattern that's called an interference pattern. We will try to derive everything today, and you will understand how that pattern comes. But let's say there is one wave which is coming from here, going till here, and I'm taking any random point, and this goes here and meets here. These are two waves, and ये तो मैंने wavelength थोड़ा अलग ही दिखा दिया. Should be like this. They meet at this point. Then what is the resultant? Either of the two things will happen. Either there will be a destructive interference or there will be a constructive interference. Yes or no? When two waves meet, either your amplitudes adds or they cancel. They don't necessarily cancel, or they subtract. Yes or no? This either of the two things will happen. And what you will find, I will try to find key, let's say key this is the center line. This is the center line, and from the center line you have some position y, and you're looking at this point P. Could be any point. I'm just looking at that point, and I'm trying to guess key what should happen there. Should there be a destructive or a constructive interference? If so, then what are the conditions that it should follow? So we'll try to derive all of it. Okay? The distance between this and this I am calling capital D, and the distance between the two slits I am calling small d. Okay? So let me write all of it. And ये center है, ये center से एक line ले लो, and going to that point, let's call it angle theta. Subtending an angle theta. Is it okay with all of you? All of this? Now if you remember, hopefully you have written till here. If you remember that when we were discussing interference, then there were some conditions for finding the interference. If you remember, there were some conditions on sources. They have to be coherent. What do you mean by a coherent source? Constant phase difference. The phase difference doesn't depend on space or time. It's an independent of those variables. Okay? So likewise we will have to have some kind of conditions on this interference as well. And let me write those conditions. So conditions for Young's double slit experiment. And the first condition is obvious, that the sources must be coherent. You have two sources S1 and S2 must be coherent. What do you mean by coherent sources? Phase difference is independent of x and t. Phase difference is independent of x and t. What could be the second second condition is this. We will make an approximation in the whole experiment that we will apply this small angle approximation. And for small angle approximation, what do you think will happen? Your distance d has to be so huge, na? If I take it to be huge, only then this angle will be very, very small. So what should be the condition between this capital D and this small d? The capital D must be much greater than small d, na? Yes. So second condition for small angle approximation. Small angle approximation. Capital D has to be much greater than small d. This leads to small theta leads to theta being small, and if theta is small, then what are the approximations we can make?
Sin theta is approximately equal to theta.
Yes, sin theta approximately theta, tan theta approximately theta, then you can in general say sin theta is approximately tan theta, and we will use that. We will use that identity. This is one condition. There is another thing कि अच्छा you have not studied electromagnetic waves, but when you do study it, you will understand that the spectrum of electromagnetic waves. What do you mean by spectrum? उसका wavelength का range. That wavelength range is in nanometers. ठीक है? It's in nanometers, so wavelength is extremely small. So that means what could be the condition between lambda and this small d? That wavelength is extremely smaller, so it's much more smaller than even this small d. So I can even write this. Small lambda is much more smaller than this thing, and this is much more smaller than this thing. Then this is one of the conditions of YDSC. That your wavelength is much more smaller than the distance between the two slits. And what was small d, by the way? I should write this. Distance between slits. What is capital D? Distance between slit and screen. Is it okay with you? These are the conditions that you have to have so that YDSC will take place. Or maybe an interference pattern will be formed. We'll try to see it by animation as well later on, and you will see how fragile the interference pattern is, in the sense that if you change even a slight condition, the pattern will go away. ठीक है?
So is it necessary that S1 and S2 should start from are in the same line?
Are in same line, yes. Otherwise that will affect the path difference. I will tell you how. But is it okay till here? Let's try to see the experiment then. And let's try to find the conditions of getting the maxima and minima. Acha, I will use a terminology here. I will say that wherever two waves interfere in such a way that they interfere constructively, there will be a point of high brightness, na? Because intensity more high brightness, then such a point will be called bright fringe. ठीक है? Bright fringe. And for those points where destructive interference occurs, then there will be intensity less. Dim point, that the dim point is called dark fringe. ठीक है? Is it okay with you? So points of maxima intensity, bright fringe. Points of minima intensity, dark fringe. So let me write it. Conditions of getting dark and bright fringes. Just a terminology that you should remember. I am writing this to be minimum intensity or destructive interference. Interference लिख देना. And this is max intensity or constructive interference. Is it okay? Now let's try to find the conditions. So I'm redrawing everything. Instead of making a 2D diagram, I'm making just a line as a screen. Please understand what it is. This is source S1, this is source S2. From this source S1 there will be a wave which is coming and hitting at this point P. So let me call this point P, and from here there will be another wave. So ये waves छोड़ के I will make straight lines for simplicity. But please understand, they are still waves. They are not rays out of a sudden. So let's make lines for simplicity. These rays will meet there. Let's say from the center I am making another line. Let's call it this. Is it okay? And the distance from here to here, so इसको white color करना है मुझे. Distance from here to here is capital D. This distance is small d. This position is some y position from the center line. You are making some angle theta from here. Is it okay with everyone? Angle theta. Let me drop a perpendicular here and let's call it point P. Okay, point C rather. Now understand this. If that angle theta is going to be so small, then can you see that this S1P and this CP, they are going to be approximately same? Approximately same length hai kya? Since the angle is going to be so small, then they are approximately same. ऐसा नहीं है angle, एकदम छोटा सा angle है. They are approximately like this. So the lengths are going to be same. So I am saying that since capital T is much greater than small d, that means theta small. So S1P is approximately equal to CP. S1P is approximately equal to CP. And what is the, how, so it's like this, huh? What is it this called, this S1, S2C? If two waves are like this one is a little behind than the other wave, na? So if I were to assume that these two lengths are approximately same, then how much is this behind? By S2C distance, huh? And what is that behind distance called? Phase. Distance को phase बोलते हैं. It's called path difference. How far, how behind you are by distance. That's called path difference. So what is this S2C? That's path difference. Let's try to see what that S2C will be equal to. Okay. Ab, let me ask you this question कि अगर ये theta है, this is theta, then what is this angle? Tell me approximately, what is this angle? Yes? Let me say it. If this is theta and all these lines are very very close to each other, na? They can be approximated to be parallel lines, then this is also theta. Then this is also theta. If that is theta, then what is this angle? If that is 90 minus theta, then what is this angle? Yeah, 90 minus theta. That will be theta. Do you understand? Approximately? Good. So let's look at this triangle again. This is my triangle, na? Where I have this theta here, I have this 90 degree here. This is S2C distance, and this is distance D, small d. Can you see that? Small d of this triangle. Now what is the trigonometric identity which will relate the two? Cos. Sab laga. Sin theta will help. What is sin theta? S2C divided by D? Then what is S2C equal to? D sine theta. And what is this S2C was supposed to be? That's path difference. And now can you see, so I will call this to be delta x. So delta is equal to d sine theta in YDSC. Now whether this delta x, so there are different delta x for constructive and destructive interference. Huh? Yes or no? Path difference is different. Now can you tell me what is the condition of getting a constructive interference on the path difference? Path difference पे क्या condition है to get the constructive interference? That's why you should revise and then come in the lectures. Let me give you some time. बताओ व्हाट इज द कंडीशन ऑन डेल्टा एक्स? अभी कुछ दिन पहले ही एक क्वेश्चन किए थे ना जिसमें एन लैम्डा, डिड यू रिमेंबर इट और जस्ट पहले? इट्स वेरी सिंपल ना, इवन इफ यू डोंट रिमेंबर इट्स वेरी सिंपल इफ यू वांट टू फाइंड इट एट द स्पॉट. कि यू टेक टू वेव्स, विल दे शो कंस्ट्रक्टिव और नॉट? दे विल शो कंस्ट्रक्टिव. व्हाट इज द पाथ डिफरेंस बिटवीन देम? The 0. And now if I want to keep on going and check, then I can extend this wave backward, and I should always compare ऐसे with ऐसा ना. I should not compare this with that. You extend this wave backwards, and now what is the path difference? Lambda, yes or no? You keep on doing it, that will be 2 lambda, 3 lambda. So what is the path difference then? N lambda. And if you were to do it for destructive interference तो कब होता है? ऐसे में होता है. तो इसको मैं एक्सटेंड करूँगा बैकवर्ड तो कितना पार्ट डिफरेंस है? लैम्डा बाई 2. और इसको मैं और एक्सटेंड करूँगा तो कितना होएगा? 3 लैम्डा बाई 2. तो यानी ऑड मल्टीपल ऑफ लैम्डा बाई 2. सो यू डोंट हैव टू रिमेंबर दीज एक्सप्रेशंस. इवन इफ यू अप्लाई सिंपल लॉजिक यू कैन स्टिल फाइंड इट. तो ठीक है. What is the condition of delta x? Is d sine theta, and it's also delta x is equal to n lambda. Then what is the condition that you get? D sine theta is equal to n lambda. And what is that n starts from? 0, 1, 2, 3, all those things. Is it okay? Acha, from this, what is sine theta? That's n lambda by small d. Yes or no? Now let's try to find where should you find the bright fringe. अब मेरे स्क्रीन में bright fringe will be formed. I got a condition for it. Where should you hope to find it? Positions. The positions निकालने के लिए I have to know this y, but for this y I will take this bigger triangle now. ठीक है? And if I take that bigger triangle, then what are the things we know from that bigger triangle? ये कैपिटल D पता है, ये y पता है, ये थीटा पता है यहाँ. Then what trigonometric identity helps? Sine. Tan से होएगा ना? What is tan? That's y by d. But for small angle approximations, tan theta is approximately sine theta. Yes? Tan theta is approximately sine theta. That means y, let me write a subscript n. Okay, that's not y into n, subscript n. Y divided by d is equal to n lambda by d. And then what is the value? Yn is equal to n lambda d by capital D. And this is the formula that you get. What does that y sub n describe? At what position will you find the bright fringe? है ना? That y1, y0, y2, what will that describe? First position, first bright fringe, second bright fringe, third bright fringe, and all those things. Yes or no? So yn is, so hopefully you have written till here.
So that big diagram.
अरे यार लिखते नहीं होगे साथ में. position of nth bright fringe. लिखो, जल्दी जल्दी हाथ चलाओ. Is it done? Copy this. Hey, idiot.
It is wrong to sleep in class. That way causing such stress.
It's wrong to pour water on others.
I was helping you, sir.
अच्छा. Can I go on? Can you already guess what is the condition for getting dark fringe then? What will be your delta xp? Just n plus half lambda by 2. No, 2n plus 1 lambda by 2, something like this. Huh? Odd multiples of lambda by 2. So condition for getting dark fringe is delta x, we found it to be d sine theta, but delta x is also 2n plus 1 lambda by 2. then what do you get then? From this I think you will get something like d sine theta is equal to 2n plus 1 lambda by 2, and that will be sine theta as n plus half lambda by d. Yes, this is the expression that we get, right? N plus half lambda by small d. Acha, I should tell you कि people always get confused between small d and capital D, because when you revise you say n lambda d by d, but what d and what d, so please be careful with that. Capital D by small d, वरना सब कचरा हो जाएगा, ठीक है? So that's this. And now from tan theta what did we find? Let me call it capital Y now. Capital Y divided by capital D, just so that you don't get confused between small yn. If I again write small yn, then you will think ये और वो same ही है. ऐसा नहीं है. So sin theta approximately tan theta. This will be n plus half lambda by small d approximately capital 1 yn, and again I am putting a subscript here. That's just showing what n corresponds to what, capital D. And then what is capital Yn? That's n plus half lambda capital D by small d. This is what we find. Is it okay with everyone? If you are done with this, then as a fun little exercise, can you tell me what is the distance between two successive bright fringes? Distance between two successive bright fringes?
Lambda d by small.
Lambda capital D by small d, right? Can you find it from n plus 1th and nth fringe? Let me write it. Everyone has written till here? अच्छा लिखो.
3 by 2 lambda d by lambda capital D by small d.
कौन सा वाला?
This one, that is dark fringe.
No. Check again.
So 5 by 2 lambda capital D by small d.
No. Try to write it and then find it.
Lambda capital D.
Yes, it will be same. Lambda capital D by small d. Yes.
It's the same.
Let me write it in terms of notes. So notes, distance between two successive bright fringes. Actually this distance is called fringe width. Fringe width, and I'm going to call it beta. In some books it's called omega, but I'm going to call it beta. Okay, this is what I remember. So the fringe width is defined to be the distance between any two successive bright fringe. That means if I take nth fringe and n plus 1th fringe, yn plus 1 minus yn, and what will n plus 1 give you? So yn was n lambda d by d, na? So n plus 1 lambda capital D by small d minus n lambda d by small d. And what do you get from this subtraction? Bolo? Should be lambda d by small d. This is beta. The distance between two successive bright fringes. What will be the distance between two successive dark fringes? That will be y, capital Y, n plus 1 minus capital Yn, and that will be n plus 3 by 2 lambda d by d minus n plus half lambda d by d. Please check if my calculations are correct. Is this correct? This is for yn and this is for yn plus 1. The 1 plus half becomes 3 by 2. So I think from this subtraction as well, you will get lambda d by small d. That's again beta. Or the distance between two dark fringe. Can you see that for a specific experiment, if you have set up everything, small d, capital D, lambda, if you have chosen those things, then this becomes a constant? Yes? And can you see this is the distance between any two bright fringe, and this is the distance between any two dark fringe. So aren't these equispaced? Yes, they are equispaced. Equispaced bright fringes. This is equispaced dark fringes. The distance between any two bright fringe is the same. Equal spacing. This is equal spacing. Yes? Now let's see how the pattern will be. So what is the distance between a dark fringe and a bright fringe? Lambda d by 2d. So it will be just the half of this. So if I have two bright fringe, then a dark fringe falls in between them. So it will be like this, the pattern. You can already guess the pattern now. There will be a bright, dark, bright, dark, bright, dark. There will be alternate bright and dark fringes. Do you get, should I repeat once more? It's understood? So the distance, let me find the distance between two, a dark and a successive dark and bright fringes. So what is the distance then? तो पहले तो अब ये फ्रिंज बाय द वे डार्क फ्रिंज का मतलब मिनिमम इंटेंसिटी ना, that will be a dim spot or maybe a dim line. So I'm just showing by yellow color bright and then by gray color dark. So it will be something like this. Yes or no? So if I want to talk about, let's say this is my first bright fringe, this is my second bright fringe, this is my first dark fringe. So I should consider the distance between the, so ये minus ये करना पड़ेगा ना, तो dark minus bright करना पड़ेगा nth है कि नहीं? तो yn, I should do this, I should do yn minus small yn. Do you understand? And not the other way around. This will give you n plus half lambda d by small d minus n lambda d by small d, and the answer will be lambda d by 2d. Yes? So you can already guess, that means that the dark fringe falls in between two bright fringes and a bright fringe falls in between two dark fringes. So alternate. Alternate dark and bright fringes. Is it okay with everyone, this discussion? So just by simple mathematics and by simple logic, we were actually able to understand the whole behavior. We were able to guess what you will find in the screen. Alternate dark and bright fringe. अच्छा ये fringe का जो shape होने वाला है, that can be many shape. The shape can be circular. The circular shape is called Newton's rings, and the shape can be lines as well. Maybe you will find lines the way in which I have made. ठीक है, you may even find dots. जहाँ पे maximum intensity का dot रहेगा and then कुछ भी नहीं, then maximum intensity and कुछ भी नहीं. Yes, so there are many ways in which that can happen, but this is all that we have. Can you now guess कि what will be the intensity distribution? Intensity कैसा दिखेगा? Will it be like कि as you go away will the intensity decrease? This is what you can hope ना, or maybe you guess कि if you have two source और मैं यहाँ बहुत दूर देख रहा हूँ, यहाँ पर point देख रहा हूँ, what will you find? तो let's see that कि क्या होता है. तो the resultant intensity that can be found out of two sources, what was the formula? Do you remember? Resultant intensity due to two sources, two waves आ रही है, meet कर रही हैं, तो एक resultant I1 plus I2 plus 2 root I1 I2 cos phi, where what was phi? That's correct formula. So let's write the intensity distribution function. I of phi. I'm going to make a simplification where I will assume that both the sources are they are identical, and by identical I mean that they will give off the same intensity. Okay, this can be achieved very easily actually. If you want two sources to be identical, just take one source. Take one source, put a bulb here, and इसका light इधर भी जाएगा, इधर भी जाएगा. Then it will give off, it will act like a coherent identical source. है कि नहीं? It's just a single source mimicking two sources because there are two slits. Do you understand this? Anyways, what was the, for any two sources, for two sources,
Is that I phi?
I of phi, I as a function of phi. For two sources, what was the intensity formula? Intensity is given as I is equal to I1 I2 2 root I1 I2 cos phi, where what is phi? The phase difference between S1 and S2. Is it okay? The phase difference between S1 and S2. This is I. But if you take identical sources, then what can I write that I1 and I2 to be? Same. And I will call it I0 for identical sources. So I am making a simplification. It will be something like I will be equal to I0. So I1 equal to I2 which equal to I0. I0 plus I0 plus 2I0. अच्छा ये I0 into I0 I0 square, take the root I0 cos phi. This will be 2I0 plus 2I0 cos phi. Is there any problem here? Then let me take 2I0 common. 1 plus cos phi. What is 1 plus cos phi? 2 cos square phi by 2 becomes 4I0, and here you get I as a function of phi. बाहर से आ रही है या फिर बॉम्ब गिरने वाला है क्या? अच्छा रिवर्स, ओके. सोचो ऐसे आवाज आई थी. I as a function of phi, 4I0 cos square phi by 2. Now do you know, so we already now we can actually predict how my function will behave, like how will it look like. Cos square phi by 2 जैसा दिखेगा ना. Do you know the cos square x का ग्राफ? Cos square x का ग्राफ पता है कैसा दिखता है? हाँ, ये y इज इक्वल टू कॉस स्क्वायर एक्स, दिस इज x. प्लॉट ऐसा दिखता है, cos x का ऐसे जाता है और स्क्वायर का ऊपर चला जाता है ना. तो हाउ विल माई ग्राफ लुक लाइक? इट्स नॉट डोमिनेटेड बट इट्स अदर प्रिडिक्टेड बाय दिस cos स्क्वायर फंक्शन ना. तो cos स्क्वायर फंक्शन जैसा रहेगा वैसे ही दिखेगा. देन हाउ विल द प्लॉट लुक लाइक? I have this screen. On the screen, how will the thing will be something like this? And it's very fascinating. It does not care about how far away you are. It only cares about the initial phase, not even this angle theta, initial phase. Once that is done, then everywhere it has the same Imax. ये मेरा दिख नहीं रहा होगा, but it is the same Imax. This is Imax ना, maximum of this. This is my intensity distribution. Resultant intensity distribution. And this is my screen. और ये मेरा distance y है, या long distance y, ये resultant distance दिख रहा है. यहाँ पर मेरा Imax दिखेगा. And what will be this value? I min? Yes or no? I min. So, can we find that Imax and I min values, by the way? It's very simple. Let's try to do it. So, no need for differentiation. This will be a destructive interference. Follows the condition of destructive interference. Then let's see. For I min, this phase and delta x has a relation. Do you remember? Acha, delta x corresponds to what for destructive interference? We just wrote it. 2n plus 1 lambda by 2. Then what will be phi in terms of delta x? What is phi in terms of delta x? 2 pi by lambda. That's 2 pi by lambda delta x. So you will be 2 pi by lambda 2n plus 1 lambda by 2, and then what do you get? You are getting an odd multiple of pi. Odd multiple of pi, but then what is my cos square phi by 2? So cos phi by 2 क्या होता है पहले ये बताओ. Cos phi by 2 will be cos of pi by 2, नहीं 2n plus 1 pi by 2. So what are these possible values? Cos pi by 2, cos 3 pi by 2, cos 5 pi by 2. What are they all equal to? They are all 0. All odd multiples of pi by 2, cos of that will be 0. You know this? For all n belonging to Indi. Do you know this symbol? Whatever I made? For all n belonging to z plus positive integers. So what will be the intensity function then? If this cos is 0, then its square is also 0, and then what is the intensity? That's also 0. So what is I? I as a function of phi is 0, and this is I min. And then can you see that this is exactly what we have plotted? The min value is 0. Now let's try to check the points at which you will find constructive interference. What you will get there? For Imax, what is Imax? बताओ. Delta x is equal to n lambda ना? For constructive, yes or no? Then what is phi? 2 pi by lambda delta x, that's n lambda. So you will get 2n pi. 2n pi. But what is cos phi by 2? That's cos of n pi. What is cos of n pi? Do you know the general equation? Cos of n pi is equal to minus 1 to the power n. Why? Because if n is odd, the answer will be minus 1. If n is even, the answer is plus 1. Yes or no? So cos n pi is minus 1 power n. Then what is cos of square? If I take the square here, that's minus 1 power 2n. But then in general this is equal to what? Plus 1 for all n. If that is so, then what is I max? That's 4I naught. Actually, I did not have to do all this trouble. I could have directly written cos square ranges from 0 to 1. Cos square ranges from 0 to 1, and I could have written directly. But let it be. So these are the maximum and minimum intensity that you find, and this is the intensity function. Can you see that we were able to actually predict everything? Just by simple principle of superposition and all those things, we were able to predict everything in the graph, even without doing experiment. We have not done any experiments. This is just pen and paper ka result. This is the power of physics. And this is the power of simple logic and mathematics. You don't need every time experiments. You can predict so many things. And what you will find, if you do the experiment, this is what I will show you. It's exactly what you will find in the experiment. Very interesting stuff. So, Acha, there is something that you should know, that obviously I made two lines. ये लिख के हो गया सब लोग का? I made this center line. Do you remember? ये बहुत पहले बनाया था. I write कितना सब लिख देता हूँ. ये एक center line है. अब इसके ऊपर भी bright and dark fringe बनेगा, इसके नीचे भी बनेगा. There will be some first bright, first dark here. There will be some first bright, first dark even from downwards as well. So when somebody asks you what is the distance between the fifth bright and the sixth dark, then the next question that you should ask is, are you talking about the fifth and the sixth from the same side or from the opposite sides? Because the distance will be different, na? If I talk about the fifth bright here and the sixth dark here, then it's totally different. Yes or no? So be mindful of this. I will give you questions right now. Be mindful of this.
So what if they don't mention it?
They will. They will always they will. Okay? Is it okay? So this is this. Now I want to show you something on YouTube, but फिर इसको pause करना पड़ेगा ना? Wait. What will the actual fringes look like if I were to make? ये तो मैंने intensity distribution function बस plot किया है. What will the actual fringe will look like? ऐसा कुछ ना? इधर बहुत ज़्यादा intensity, इधर भी, because they correspond to maxima, and then what? इधर minima. ऐसा. Do you understand? Alternate dark and bright fringes. So please make the diagram and please use some color coding. Acha, why did we find, let's just for fun, why did we find I min to be 0? Can anybody answer that?
Light does not fall.
No, light does fall, तभी तो interference हो रहा है. वो उधर light हो के भी नहीं है. That's very interesting. Anyways, you tell me कि why is I min 0 here? Come on. No yaar, it's so obvious. I know destructive. But there can be ways in which that's not completely 0. Dim होएगा लेकिन 0 नहीं होएगा. Can anybody answer? It's a very simple answer. It goes back to our assumption that we assume this. What if they are not? You remember I told you we assume this. You remember that if destructive interference occurs, then the amplitudes is mod of A1 minus A2. And if you take A1 equal to A2, then that becomes 0. But if A1 is not equal to A2, it's some minimum value which is non-zero. So don't be surprised if you get some questions where this I min is not 0. Some minimum value which is not 0. in those questions the intensities are not same. Does it make sense? Everyone? Good. तो इसको ज़रा pause करो so that I can show you that. Everyone has written till here, ना? What? नहीं हो रहा क्या?
And we had this is very
Tell me.
pointed, right? So I just tapped it.
Is it resumed? Oh, गिर भी गया था. Very good. Let me write a question. बोला. For two what? Intensity will be same. That's very interesting that we find that. Exactly. This is the graph that we find. Intensity is same. ठीक है? So I'm writing some questions now. So question कहाँ गया? Yes. Let's attempt this one. जो Don't talk. Copy the question and then attempt it. Don't waste time. Attempt. I'm giving you 3-4 minutes and then I will start. Hmm. 0 point. Be more specific. 0.8 के आगे भी कुछ है. करो करो डिवाइड करो. 1 point?
5 cm.
Incorrect.
This will not be applicable. This is only applicable for these conditions, right?
Yes.
I don't want this is disproven, right?
It's not disproven. You will not find the screen के ऊपर वो pattern नहीं दिखेगा. Whatever we are, there will be superposition obviously, but it will not have that pattern. What we are finding.
स्पेशल केस
हाँ, यही कंडीशन के ऊपर वो पैटर्न दिखेगा तुम्हें, बस इसके अलावा पैटर्न नहीं दिखने वाला है. बोल. इनकरेक्ट. जाओ ये 50. इनकरेक्ट. Come on, it's such a simple question. Give me an answer. I will start in 2 minutes. Incorrect. It's so simple.
12.2 into 10 to the power.
Incorrect. Yes. Come on, give an answer. Zero point 825. गलत. डिवीजन वापस सही से करो. एटी. Incorrect. Okay then. It's not that hard. क्या है ये? सब्स्टिट्यूट करके बस लाना है आंसर. We're talking about YDSC. Two slits are separated. Small d is given, capital D is given, wavelength is given, and now you have to find the distance between 7th maxima and 11th minima. 7th maxima के लिए from where does the n starts? 7th maxima के लिए y7. So distance निकालने के लिए positions पहले निकालने पड़ेगी ना. What is the position of 7th maxima? That's n lambda d by d, 7 lambda d by small d. अब 11th minima के लिए n starts from where? 0 या 1? 0 से start होता है. तो 11th मिनिमा इज इक्वल टू कैपिटल वाई 10, दैट्स n लैम्डा, n नहीं क्या है, n प्लस हाफ लैम्डा डी बाई डी ना, तो 10 प्लस हाफ lambda d by small d, and that will be 21 by 2 lambda d by d. Yes or no? Then what is the separation between the two? y10 minus y7, that's 21 by 2 minus 7 lambda d by small d, that will be 7 to the 14 minus 7, तो 7 by 2 lambda by d by d. यही आना चाहिए. And now substitute and get the answer. So 7 by 2 lambda 5000 angstrom. D, capital D कितना है? 0.5. What is small d? 0.5 10 power minus 3. अब this can be written as 7 by 2 5 into 5. Yes or no? This power minus 4 goes up above, becomes plus 4. Listen, power minus 4 goes up plus 4 and then plus 3 plus 7 plus 7 minus 10 minus 3 minus 3 minus 1 10 power minus 4, and then you have 5 times 5 25, 25 times 7 175, 175 divided by 2 87.5. करेक्ट किया है ना, देखो जरा, दैट्स 8.75 पावर माइनस 3 मीटर्स, दैट्स 8.75 millimeter. Okay. It was that simple. What you were doing wrong, I don't know. Everyone was getting different answers. क्या चीज़? y11 ले लिया. n starts from 0 ना. So be mindful of that. नहीं समझ आ रहा है. क्या बोल रहा है? जाओ जाके वापस इक्वेशंस देखो और उसके बाद पूछो, ठीक है? कैन आई राइट वन मोर क्वेश्चन, टेक इट एज अ होमवर्क एंड देन वी कैन डिस्कस इट टुमारो. एवरीवन हैज रिटन टिल हियर? लिख लो, इतने में मैं क्वेश्चन लिख लो. जाओ. Don't talk. There's 5 minutes left. Be like a human for 5 minutes. Then you can convert. Okay, take this as a homework question, and I'm not teaching anything more than this for today. If you are done, you can take the break.